Drink Real Milk 2026. This series is about understanding milk from the body's point of view, not from marketing or ideology. We are not promoting any brand, any industry, or any political position. This is purely evidence-based education. We will look at how different types of milk, full fat, low fat, skim, fermented, A2, lactose-free, and plant substitutes affect insulin, gut health, and overall metabolism, especially in people with insulin resistance, fatty liver, or metabolic syndrome. The key message from modern research is that whole food dairy behaves very differently in the body compared with refined carbohydrates, and that the metabolic context matters more than simply the fat percentage on the label. This information is for education only. Individual tolerance varies, especially with lactose intolerance, gut conditions, and diabetes. So any major dietary change should always be discussed with your own doctor. The scientific foundation for discussion includes work by Astrup and colleagues in the Lancet Diabetes and Endocrinology, showing that dairy fat, when consumed as real food, does not behave the way older low-fat theories predicted. So the goal is simple: to help people understand what their body actually sees when they drink milk and how to make informed, calm, evidence-based choices in 2026. No fear of whole milk for children. Current evidence shows that whole milk does not make children fat. In fact, it may help regulate appetite better than low-fat milk. This aligns with the current shift in the US dietary guidelines 2025 to 2030, away from the automatic low-fat recommendations for children. No fear of whole milk also for healthy adults. In healthy adults, whole fat milk does not increase heart disease or obesity risk, and in many studies is associated with better metabolic health and lower diabetes risk, especially when replacing refined carbohydrates. If you are insulin resistant, diabetic, or overweight, caution with milk. Milk is a unique food. Even though its glycemic index is low, it produces a relatively strong insulin response. This has been shown in classic studies by Jenkins and Ostman, where milk stimulated insulin more than expected for its sugar content. The reason is that milk is a liquid carbohydrate protein combination. The lactose is absorbed quickly, and the whey protein are highly insulinogenic. So the pancreas releases insulin even though the blood glucose rise looks modest. For someone who is insulin sensitive and active, this is usually not a problem. But for people with insulin resistance, type 2 diabetes, fatty liver, or significant overweight, repeated insulin spikes from large or frequent milk intake may slow fat loss and may worsen insulin resistance over time. This does not mean milk is bad or forbidden. It means context matters. How much you drink, how often you drink it, whether you drink it with meals or alone, your personal metabolic and gut tolerance. So the practical message is moderation, timing, and individualization. Small amounts with meals may be fine for many. Large glasses between meals, frequent lattes, or using milk as a main calorie source may not be ideal for those trying to reverse insulin resistance. As always, this is education, not prescription. People with diabetes or metabolic disease should individualize intake and discuss it with your doctor or dietitian. Whole milk versus low-fat milk. When we remove fat from milk, we do not just change calories, we change how the body processes it. Whole milk empties from the stomach much slower because fat delays gastric emptying. This leads to a slower rise in blood glucose and insulin and produces greater satiety. People tend to feel full for longer and snack less afterwards. Low fat and skim milk, on the other hand, behave more like a sweet liquid protein drink. The lactose is absorbed faster, the insulin response is quicker and often higher, and satiety is shorter. This can be relevant for people with insulin resistance, diabetes, or those trying to lose abdominal fat. Milk fat also carries fat-soluble vitamins, particularly vitamins A, D, and K, which are important for immune functions, bone health, and metabolic signaling. Removing the fats reduces natural delivery of these nutrients, even if some are later added back synthetically. Large population data, including the pure study published in The Lancet, showed that higher intake of whole fat dairy was not associated with higher cardiovascular risk, and in some analyses was associated with better metabolic outcomes compared with low fat dairy. So the modern message is not simply less fat is better. It is that food structure, digestion speed, hormonal response, and satiety matter more than fat percentage alone, especially in people with insulin resistance. A1 versus A2 milk. Not all milk proteins are the same. The main difference here is the type of beta casein, A1 versus A2. When A1 beta casein is digested, it can release a peptide called BCM7. This peptide has been shown in experimental studies to slow gut transit and may trigger discomfort in some people, particularly those with sensitive intestine or bloating. A2 milk contains only the A2 form of beta casein and does not release BCM7 during digestion. Several human studies, including Jiang et al. Paper in Nutrition Journal, show that some people report less bloating, less abdominal pain, and better digestive comfort when they switch from conventional A1 milk to A2 milk. Importantly, this is not about allergy and not about lactose. Many people who think they are lactose intolerant actually tolerate A2 milk better, suggesting the protein, not just the sugar, can be part of the problem. This also does not mean that A2 is superior for everyone. Many people digest A1 milk perfectly well. But for those with gut sensitivity, IBS type symptoms, or discomfort after milk, trying A2 milk is a simple, low-risk option before eliminating dairy altogether. So again, the theme is individual tolerance. Milk is not one uniform substance. Its protein structure matters, and the gut response can differ from patient to person. Raw milk. Raw milk is often discussed in two different ways, from a biological point of view and from a microbiological safety point of view. From a biological perspective, raw milk contains live bacteria and natural enzymes. Some people believe this may support digestion or immune signaling, although high-quality clinical evidence for long-term benefit is limited. From a microbiological perspective, however, raw milk also carries a real risk of harmful pathogens such as E. coli, Salmonella, Listeria, and Campylobacter. These organisms can cause severe illness, bloodstream infection, miscarriage, or even death in vulnerable people. Long surveillance data from the CDC and other public health agencies constantly show that outbreaks of foodborne illnesses are far more common with raw milk than with pasteurized milk. High groups should clearly avoid raw milk: pregnant women, infants and young children, elderly people, anyone with diabetes, cancer, autoimmune disease, or a weakened immune system. So, this is a classic example of biology versus microbiology. While raw milk may contain live organisms and enzymes, it also carries unpredictable infection risks that modern pasteurization was specifically designed to prevent. For most people, especially those with metabolic disease, the small theoretical biological benefits do not outweigh the well documented safety risks. This is why major medical and public health bodies continue to advise against routine raw milk consumption. UHT and powdered milk. Ultra heat treated milk and powdered milk are produced by exposing milk to very high temperatures to make them shelf stable and microbiologically safe. This high heat processing denatures some proteins and inactivates natural enzymes. The milk is still nutritious in terms of calcium, protein, calories, but its biological structure is altered compared with fresh, gently pastured milk. The advantage is safety and convenience. UHT and powdered milk can be stored for long periods without refrigeration and are extremely useful in many parts of the world. The trade-off is that heat-sensitive components, including some bioactive peptides and enzymes, are reduced. This may change digestion speed, gut interaction, and hormonal response compared with fresh milk. So the key message is not that UHT or powdered milk are bad, but they are biologically different foods. They are safe and practical, but they do not behave exactly the same in the body as fresh whole milk. Again, the theme of this series is context. Processing changes food structure, and food structure influences digestion, insulin response, and satiety. Plant-based milks such as almond, soy, oat, rice, and coconut drinks are widely used today, but nutritionally they are not the same as cow's milk. Cow's milk is a naturally complete food containing high quality protein, calcium, phosphorus, vitamin B12, iodine, and fat soluble vitamins in a highly bioactive form. Most plant milks are much lower in protein and minerals unless they are heavily fortified. Many plant milks are also ultra processed. They often contain added sugars, vegetable oils, stabilizers, and emulsifiers, and the nutrient profile depends largely on industrial fortification rather than natural food structure. This does not mean plant milks are bad. They can be useful for people with true milk allergy, vegans, and those who choose them for cultural or personal reasons. But they should not be presented as nutritionally equivalent replacements for real milk, especially for children, older adults, or people with metabolic disease who need adequate protein and micronutrients. So the key message is plant milks are alternatives, not equivalents. They can fit into a diet, but they do not provide the same metabolic, protein, or mineral package as whole dairy. The central message is that milk is not a simple neutral drink. It is a biologically active food that influences insulin, appetite, and gut comfort. How the body responds depends on the fat content, the amount of protein, A1 versus A2, the degree of processing, and the individual's metabolic state. For healthy children and insulin-sensitive adults, milk can be a valuable, nourishing food, providing high-quality protein, calcium, and fat-soluble vitamins. For people with insulin resistance, type 2 diabetes, fatty liver, or central obesity, milk needs to be approached more thoroughly. Portion size, frequency, timing, and the type of milk all matter. In this group, moderation and personalization are more important than the blanket advice. So, the modern evidence based position is not milk is good or milk is bad, but milk is context dependent. Understanding your own insulin sensitivity, gut tolerance, and overall diet pattern allows milk to be used wisely rather than automatically or exclusively. This is what Drink Milk 2026 is really about. Not ideology, not fear, not marketing, but helping people understand what their body actually sees and make informed, individualized choices. Thank you for watching.